Good afternoon to one and all. And today the concept is about symbol table and where it is the fifth unit as per our syllabus. I am starting this unit with what the introduction or what the definition of this symbol table is, and then going in depth of each and individual concept in the symbol tables, right? So here we all know what the symbol table is and what's the role of the symbol table. We're having six phases of process of compilation. In those, along with those 6 phases, we're having two subphases, right? What are those two subphases? One is a symbol table and the other one is an error handler. So here, the symbol table is a data structure. And how I define the symbol table means it is a data structure. From the starting of the course compiler design, in the process of compilation, I explained this. Symbol table is a data structure, and what the role of the symbol table is, everything that is going to be stored as a database here, and whatever the implementations that we are going to perform in each and every phase, everything is going to be stored in a symbol table. That means we are maintaining it as a record here, and with that record we are using that record in the form of either to edit or edit in the sense either to update or delete or add anything or anything else. So this is a record. And here what the other subphrase is, it is about an error handler. And here the error handler is handling the errors. What the role of the error handler is? To handle the errors. That means in the each and every phase itself, we are encountering some commonly occurred errors, and those commonly occurred errors are we find out those and we debug those, and finally we modify the code, and at last we are generating an error-free code as an output. And at each and every phase itself, we are using these two subphases. What those two subphases means? One is a symbol table and another one is an error handler. These are the subphases of the process of compilation. And we are having mainly 6 main phases: lexical analyzer, syntax, semantic, intermediate code generator, code optimization, and finally code generation. And from starting of the source program and ending of the target program, here we are implementing the pre-processing technique. With the pre-processing technique, the overall process of comparison can be done in phase by phase level. And here each and every phase is connected to the symbol table along with the error handler. Why? Because and in the symbol table we are storing everything. We are storing everything whatever we done in the phase itself. And as usually in error handler, by using this error handler, we are handling the errors at phase by phase level itself. I think you all understand, because this concept was already explained in the starting of the course compiler design. In the phases, in the concept like in phases of compiler, we are having 6 phases and 2 main subphases. And once recall the structure of the phases of compiler and just recall what the symbol table and what the error handler is. And here totally we are talking about the symbol table from this session onwards, because here we are knowing what the concepts in detail about the symbol table, how the symbol table was managed and how the symbol table was organized, and everything in detail concepts we are going to learn here under the symbol table. And now, knowing about what the definition of the symbol table is. As already said, that symbol table is a data structure and it is used by a compiler, right? And by using the compiler uses this symbol table as a data structure, and it always keep track of the semantics of the variables. What it means is, here the symbol table stores the information about the scope and binding information about the names. We are having two types. One is a scope and one is a name. That means information about the scope we are storing in the symbol table, and also binding information about the names we are storing in the symbol table. And how the symbol table acts as here, just we are using the symbol table for the storing purpose. That means storing the information, right? Information about everything that we are implementing in the process of compilation. And here, this symbol table is built in lexical and syntax analysis phase. And default, it was built in both the phases like a lexical and the syntax analysis phase. That means the first phase and the second phase. And next, this symbol table is used by various phases And here the semantic analysis phase refers the symbol table. Why it refers means for type conflict issues, it refers the symbol table. And while coming to the code generation phase, because in the last class I explained about the code generations, right? So in code generation, it refers the symbol tables just knowing how much runtime space is allocated. How much runtime space is allocated. And along with that, what type of runtime space is allocated. These two informations can be taken from the symbol table itself. What it means is, if you retrieve the data from the symbol table about the code generation, then you can know how much runtime space is allocated and what type of runtime space is allocated for the code generation and what type of an information is stored in the symbol table. And these are the most important points that we need to remember while talking about the symbol table. And the most important thing is symbol table is a data structure. Don't forget this. Symbol table is a data structure. And this data structure is used by the compilers. If I want to compile any type of a source program, I need the data structures. And how I am maintaining these data structures in the form of the symbol tables. And what I am doing with this, just I am keeping track of all the semantics of the variables and what I implement, and in the place of this variable, what the identifiers or the tokens that I use it for that. All this information can be stored in the symbol tables. And here, this is used throughout the compilers to hold the information about various entities in the source program. Here we are having different entities, right? And what the entities means, for example, the classes can be called as an entities or instances can be called as an entities, methods, variables, and etc. And the properties of those entities, for example, I need to know the properties of the class, type, instances, arguments, visibility, memory requirements, all these are comes under the entities. And here holding the information about the various entities, and those entities are in the form of either it may be a class entity or instance or method or variables. And after defining the entity, then you need to define the property of that particular entity in the form of like types, arguments, visibility, memory requirements, etc. And here the information is collected incrementally, because from starting from phase 1 to phase 6, what we're doing, we're improving. We're improving the process of compilation, right? So here the information is collected incrementally, and this information is used by the various phases of the compilers. What it means is, for example, I implement the lexical analyzer and I generated an output. There itself, I maintain the symbol table as a record, and along with the symbol table, I encounter the errors by using the error handlers, isn't it? And here, whatever the output I am generating from the lexical analysis, that output is taken as an input to the next phase, that is syntax analyzer, right? So what will happen if whatever the output I am generating, the subsequent output is generated from phase by phase level itself. That means here I am using the pre-processing technique. I am implementing the pre-processing technique. What it means here, whatever the information that I collected, it can be collected incrementally, and the information is used. And whatever the thing that I stored in the symbol table, and that information is used for implementing the syntax. And for the semantic, I am retrieving, I am searching in the symbol table for some input. So incrementally, I am collecting the information, and that information is used by various phases of the compilers. And next, what the components of the symbol table? I think do you all understand the definition of the symbol table? And the symbol table is a data structure that is used by the compiler just to keep track of the semantics of the variables. Or it can also be defined as the symbol table is used throughout the compiler to hold the information. Which information that we are holding? The symbol table holds the information about the various entities in the source program. What the entities are, these are the entities, right? And storing the information means storing the information about the scope and binding the information about the names. That's about the definition of the symbol table. And now coming to the components, the next fundamental thing that you need to know about the symbol table is you need to know what the components of the symbol table is. What the components of the symbol table here? We are having two main components. What and what? One is a name table and the other one is an entity table. Or name table means this table is used to uniquely identify different names that occur in the program. And what the entity table? And here each entity in the program is represented by a unique entry in the entity table. And these are the two most important components of the symbol tables that we are using here for generating the symbol tables from the code, from the program, right? And here, one thing you all need to know, and here we're talking about the symbol table and its entries. Entry in the sense, we're having two types of components. One is name table and the other one is an entity table. And totally the entity table means each entity in the program is represented by unique entry in the entity table. And here, to achieve compile time efficiency, the compiler makes use of symbol tables. All of you note down this. To achieve compile time efficiency, because we need an efficient target code, right? To achieve the compile time efficiency, the compiler makes use of the symbol tables. And always it associates the lexical names with their attributes. And here, the items to be stored in the symbol to table. What the items are, what the items that we are using here is, it may be variable names, constants, procedure names, and the function names, literal constants, and the strings. All these are all comes under the items. These are all the items that are going to be stored in symbol to table. Again, I am repeating what the items are: variable names, constants, procedure names, function names, literal constants, and strings. And these can be called as an items, and these are to be stored in the symbol to table. And next, we are having some compiler generated temporaries. Those are also being stored in the symbol table. And some labels in the source languages. What the labels? You all know what the labels are. L1, L2. When we name it for the basic blocks, it is label 1 and label 2. Or when we are implementing the intermediate language, at there we are using label 1 and label 2 like that. And these labels in the source languages are also to be stored in the symbol table. And here we're having some types of information from the symbol tables. And these types are used by the compilers here. What the types means? One is a data type, and another one is a name, and the next one is a declaring procedures and offset in storage. And here where if you use if structure or record to the pointer to structure table, all these are all comes under the types of informations. And that means these types of information you're already stored in, these are all already stored in the symbol table, and the compilers use these from the symbol table itself, right? For parameters, whether the parameter passing is by value or by reference, or number and type of arguments that are passed to the function, or base addresses, all these things, all these the types of informations from the symbol table are to be used from the compilers. And most important thing is you need to know about what the components of the symbol tables. Two components we are having here, name table and entity table. And in the name table only we are using an unique identity, uniquely identify different names that occur in the program. And in the entity table here, each entity in the program is represented by an unique entry in the entity table. And coming to the operations of the symbol table, here we are having two most important operations. And one we are using for the insert, and another one we are using for the lookup. Insert of name, look of name. Insert of name means it here makes an entry for this name. By using this operation, we are making an entry. That is, we are creating an entry for this name. And lookup of name. And here, what we are doing with this operation means we are finding out the relevant occurrences of the name just by searching the table. Here, we are insert and search. We are doing two types: insertion and the searching, right? And search with lookup of name function or operation, and insert or create with insert of name operation. And here the lookup occurs a lot more often than the insert. And what the functions are, what the symbol table functions are. In addition to the lookup and insert, we are having some other functions. What and what are? First, initialize scope and finalize scope. And here we need to manage the symbol tables, right? And why to manage the symbol tables means for insertion or for searching anything, we need to manage those. So for managing of those, we are having some methods here. Some methods in the sense we are having some requirements. The requirements for the symbol table management are, and first for quick insertion or for quick searching, what you need to insert, any type of an identifiers or any related information I need to insert, or what you need to search for, I need to search for any type of an identifiers that I used in the phase 1. And here we're having some commonly used data structures for this symbol table management. What those data structures means: list data structure, list, linked list, self-organizing list, and binary trees, hash tables. All these are all the data structures that we use for symbol table constructions. So when we are managing the symbol tables, we are using these two most important functions. What are those two means? Initialize scope and finalize scope. Initialize scope and finalize scope. At the starting of the definition itself, I spelled out the word like in scope. Did you all remember that? What the scope means? What the scope means? Here, storing the symbol table means the symbol table stores the information about the scope. That means, and binding information about the names. And what we are storing in the symbol table, we are storing the information about the names. So here we are having two functions. What those two functions means: initialize scope of level and finalize scope of level. And what the function initialize scope of level means: when a block is entered to create a new hash table, here as I already explained you, if you want to insert or if you want to create, right, I need to use the function like an initialize scope of level. And with this function, a block is entered to create a new hash table and the entry in the symbol table is. And finalize means I want to exit from the block. So I will use the finalize scope of level. On block exit, put the current hash table into the background list. By using this function, block exit can be done, and by using the initialize scope function, block entry can be done. So here overall we are using two most important functions: initialize scope and finalize scope. See, in the last slide, what I explained you about the operations, two operations. What are those? Insert of name, lookup of name. Insert, create, right? Create and lookup for searching, finding out. Is it clear now? Insert is nothing but an insertion. Lookup is nothing but an searching. And if you want to done quickly, if you want to implement quick insertion and quick search, then you need to choose for the requirement. Then you need to choose for different data structures here. Based on the requirements, you need to choose the different types of data structures. And here, see, this is the sample program to compile. And let's see how the symbol table is generated from this. This is the sample program. And what the fields that the symbol table consisting of means, it consisting of 4 fields, mainly 4 fields: symbol, token, data type, initialization. Symbol is nothing but a symbol, a variable. Token is we are defining the token name for that variable. And data type is nothing but a data type. Initialization function argument or not. If it is a function argument, it is